Okay guys, so you're welcome to this class. We'll be looking at implicit derivatives, and I told you that derivatives are also called differentiation functions. So whenever we differentiate functions, we are looking for the derivatives of these functions. Okay, so we'll be looking at implicit. Now the implicit differentiation focuses basically on the implicit rule. And the implicit rule is applied for implicit functions. What are implicit functions? Implicit functions are those functions that have both x and y. Explicit, only x. Alright? So we have a couple of exercises here that we use to juxtapose the concept of implicit derivatives. Alright, so we're starting with the first one. Number one is x plus y equals to 30. We are told to determine the derivative. Whenever you're told to determine derivative, what you're being told to look for is to look for dy over dx. Now look at this quickly. Whenever we are differentiating x, we use what we call the power rule. At least that's like the basic rule of differentiation. Axn equals to n times ax raised to power n minus 1. Okay, but if we have just x like this, x is 1, right? So x is 1 plus, whenever we are differentiating y, we differentiate y the same way we differentiate x. But what we do is that after writing the derivative of y, we write dy over dx together with it. Is that clear? Is that clear? Alright, so differentiating y is 1, but we will now write dy over dx. It is a rule and it's standard. All the time it should be like this. Now, 30 is a constant on the right hand side. 30 is a constant. And whenever we are differentiating constant, remember it's 0, right? Thank you. So 30 is 0. Now, the idea is this. When you have differentiated, listen, when you have differentiated every component of your implicit function, the idea is to make your dy over dx subject to the formula. Which means that you must ensure that everything that contains dy over dx is on your left hand side. The things that do not have dy over dx is on your right hand side. Are we together? Yes. Alright, so it means that we have 1 dy over dx equals to, this one does not have dy over dx, right? We move it over, so this will become minus 1. Remember, 0 means nothing, right? So 0 is almost empty there. Alright, so we divide both sides by 1. Divide both sides by 1. If 1 cancels 1, our dy over dx will be equals to what? Minus 1 over 1 is what? Minus 1. This is our answer. Okay? This is our answer. Now let's quickly go to the second exercise. Now the second exercise, we have y. Okay? Let's differentiate y. Alright, so differentiating y, we will write 1 dy over dx, right? Right? Okay, plus 15 is a constant, so it is what? 0. Equals to differentiate x. Do we put dy over dx? No, because it's not y. Then plus what? 0. So this will be 1 dy over dx equals to what? 1. What do we do? Divide both sides by what? By 1, right? Is it not? So cancel, it means that our final answer, dy over dx will be equals to 1 over 1 is what? 1. Alright? So we'll be doing number 3, minus x squared plus 2y minus what? 40 equals to 100 plus y, right? Now look at this, guys. Minus x squared is minus 2x, am I correct? Minus x squared is minus 2x plus 2y is 2, right? But because we differentiated y, we write what? Dy over dx. Minus 40 is a constant, right? So it is 0. Equals to, there's no need writing 0. Right? It's just like we have discarded it. 100 is a constant, right? So differentiating a constant, 0. Differentiating y is what? 1 dy over dx. Thank you. Alright. Please, at this point, once you have differentiated, you don't differentiate again. Rather, you take like terms, make the y over dx subject to a formula, and you write your final answer. It's not supposed to be tedious after differentiating. Alright, so what we have to do now is to ensure that everything that has dy over dx is on the left hand side. The ones that do not have dy over dx is on the what? Right hand side. So it means that this will be 2 dy over dx. This guy has dy over dx, right? By the time we move into to become what? Minus 1 dy over dx. This man does not have dy over dx, right? Crossing the equality sign becomes what? 12. Are we together? Alright, so 2 minus 1 is what? 1. So we just say what? dy over dx. 2 dy over dx minus 1 dy over dx is just what? dy over dx, right? So dy over dx is equals to what? 2x. So that's the final answer. So that's the dy over dx. Alright? Now, sometimes we can still do this. Let me show you something we'll be doing subsequently. The reason why I just say 2 minus 1 is because the coefficient of dy over dx here are just whole numbers. And 2 can subtract 1. How about a case where the coefficients cannot subtract themselves? What you do is factorization. So for instance now, look at this guys. For instance now we have 2x dy over dx minus 1 dy over dx. If this was what we had here, if there was x here, what is common here? Dy over dx, right? So we write dy over dx, then we factor out 2x minus 1. Then we have to divide both sides by 2x minus 1. The reason why I just said 2 dy over dx minus 1 dy over dx, I repeat, is because 2 and 1 are actually very like terms. And 2 can subtract 1, right? And 2 minus 1 is what? Is 1. Are we together? Alright, thank you. So that is that. Okay, so now let's quickly go to the next exercise. So we have but before then, I would like you to attempt something before we look at the next exercise, which is the fourth one. So I would like you to solve this. I'd like you to solve this quickly. Now let's say we have 9x squared plus 10y cubed equals to 50 minus 6y raised to power 4. Find dy over dx. Okay, so solve that quickly. All right, so we'll be looking at number 4. We have 2xy plus 6x squared minus 3 equals to 5x plus 5y raised to power 4. Now if you look at number 4, you would realize that it's not like number 1, 2 and 3. It's not the norm. In fact, the one I told you guys to actually attempt is not also like it. What is the difference? The significant difference is the fact that x and y are together, right? Significant difference is that x and y are together. So now, whenever x and y are together, listen, we use the product rule. We use the what? Product rule. And remember, the product rule is u dv dx plus v du over dx. We use the product rule. Alright? But see, I always like to make it to be simpler. I always like to make it easier for students to understand, especially when it comes to using product rule inside implicit. Alright? So now, look at what I want you to do. Look at what I want you to do. We have 2xy. We have 2xy plus 6x squared minus 3 equals to 5x plus 5y raised to power 4. Okay, the idea is this. Let me just make it simple. Open a bracket. It should be a big bracket because you want to differentiate 2x, y. See what you have to do. Keep the x constant. Differentiate the y. Plus, keep the y constant. Differentiate the x. Why I say keep the x constant? See what I mean? This 2 is affecting what? Only x. Are you hearing me? This 2 you're seeing here is affecting just what? X. The product rule states that, look at your x, your 2x. This 2xy you're seeing here means 2x times y. Am I correct? 2xy means 2x times y. That's what 2xy means. So take your 2x as u. Take y as v. Take your 2x as u and take y as what? V. So now look at it. Don't get it twisted. Look at it this way. Your 2x, any number, coefficient, if we have something like say, okay, now let me use this as an instance. Minus 3x squared y squared. This minus 3 belongs to what? This minus 3 belongs to what? X squared. 2xy squared, this 2 belongs to what? X. This 2 belongs to x, not this 2 belongs to 2x. This 2 belongs to what? X. Okay? Minus 3x squared y squared, this minus 3 belongs to what? X squared. X squared. So it is minus 3x squared and y squared. So now the idea is this. Keep your 2x constant. Write your 2x. Differentiate your y. Multiply it by the differential form of your y. Put it in, open another bracket. Open another small bracket inside. Differentiate y is what? 1 dy over dx close. Plus, open another bracket. Differentiate what? Keep y constant. Keep y constant. And differentiate what? 2x. It will be what? 2 times what? 2. Like that, you have finished your 2xy. Keep your 2x constant, like keep it, bring it down, differentiate y. Keep your y constant, differentiate what? X. It's just like you don't touch x, you touch y. You don't touch y, you touch x. Do you get it? You don't touch x, so you don't touch x, you touch what? Y. You don't touch y, you touch what? X. So if you don't touch x, it's 2x, because 2 and x are together. If you touch y, it's 1 dy over dx. If you don't touch y, it is y, right? If you touch x, it is what? 2. Thank you. Minus 3 is a constant, right? So it is 0. Okay, but even before that, let's not differentiate 6x squared first now, is it not? Yes. So this will be plus 12x. Minus 3 is a constant, so it's up. This will be equals to 5 plus 20y cubed dy over dx. Is it not? 4 times 5 is what? So 20y, 4 minus 1, then dy over dx. Remember when we are differentiating y, those ones we've already resolved those ones now. Okay, what's the issue? Why does my y times 2? Why doesn't it have the y over dx, right? Beautiful question. Now, because we did not differentiate y. Because we didn't differentiate y. In product rule, let me repeat. In product rule, keep your x constant, differentiate y, plus keep your y constant, differentiate x. So if we differentiate our 2, if we keep our 2x constant, it's 2x, right? If we differentiate our y, it is 1 dy over dx. If we plus, open another bracket, if we keep our y constant, it is y. If we differentiate our x, which is 2x, it will be what? 2. Is it clear now? Alright, so 2x times 1 dy over dx will give us 2x what? Dy over dx plus y times 2 is what? 2y plus 12x equals to 5 plus 20y cubed what? Dy over dx. So what do? We bring everything that has y over dx on the left hand side. So this will be 2x dy over dx. If we move this 20y, it will become minus 20y cubed dy over dx. Then the things that do not have dy over dx, we move it to the right hand side. This will be 5 minus 2y minus what? 12x. Are you seeing it? 5 was already here now. I moved 2y, it became minus 2y. I moved 12x, it became minus 12x, right? So what we have to do now, let us factor out dy over dx. So if we factor out dy over dx, we'll be left with 2x minus 20 what? Y equals to 5 minus 2y minus 12x. Remember here we have cube, right? We have cube. So now divide both sides by 2x minus 20y cubed. 2x minus 20y cubed. Alright? So what are we going to get? If this cancels this, it means that dy over dx would be 5 minus 2y minus 12x divided by 2x minus 20y cubed. That is our final answer. That's our final answer. Okay? So that's our final answer. Okay guys, so we'll be doing number 5. We have minus 3x squared y squared plus 100x squared equals to 6x cubed minus 45. Alright, so if you look at this guy, if you look at it, you realize that x and y are together, right? Right? Like I told you, when x and y are together, just like we did in the other example, we use what rule? Product rule. And product rule is simply keeping your x constant, differentiating your y, put in bracket plus, keeping your y constant, differentiating your x. Is that clear? Alright, so now look at these guys. So this would be, open a bracket. We are doing number 5. Open a bracket, then open a small bracket inside for x. Okay? For x and y plus the other side. Now, keep x constant. If you keep x constant, it will be what? Minus 3x squared. Look at your x here, then look at your y. Minus 3x squared is for your x, y squared is for your y. Okay? Minus 3. I told you that this the coefficient that starts that particular function is for x. Do you understand? The coefficient that starts that minus 3, just like here, 2 is for what? Not for y. It's not for x and y. Okay? It's just for what? X. Alright, look at these guys. So keep x constant. Differentiate y. If you differentiate y squared, you have what? 2y what? Is it becoming clearer now? Thank you so much. Close the bracket. Then put plus. Open another bracket. This time you will not keep x constant again. This time what will you keep constant? And you differentiate. Thank you. So if you keep y constant, it will be what? Y squared times minus 6x. Minus 6x. Close. Then you close the bigger bracket. Close the bigger bracket. Then you come here and do the normal thing we have been doing. Plus 100x squared, 200x equals to 6x cubed, 18x squared. Minus 45 is what? 0 because it's a constant. Alright, so now let us finish this guy. Let's finish this guy. Minus 3x squared times 2y. Okay, let's take it step by step. Let's multiply the coefficients first. Minus 3 times 2. Minus 6. X squared times y. X squared y. Then dy over dx. Plus, what is the coefficient here? 1 times minus 6. Minus 6, right? Minus 6. Remember, this plus now will change to minus. So can we clean this off? Because plus times minus is minus, right? So minus. Minus. Are we together? Are you sure? Alright, so minus 6. X usually comes before y, right? So y squared times x. X, y squared. X, y squared. Plus what? 200x equals to 18x squared. Luckily here, we have only 1 dy over dx, right? So it will be easy. So we can just say minus 6x squared y dy over dx. Luckily for us, the y over dx is already on the left hand side, so there's no need moving. Now this will be equal to, rather we'll move everything that does not have dy over dx over there. So this will be equals to 18x squared minus 6y squared will turn to what? Plus 6xy squared plus will turn to what? Minus 200 what? X. Are we together? Alright, thank you. Thank you. So now look at these guys. Look at this. Take a good look at this. There's something we'll do here. We'll now have to divide both sides by what? Minus 6x squared y. Minus 6x squared y. Are we missing something? What is it? Alright. So, are we missing anything? Okay, now look at this. So, this will cancel, right? Okay. Alright. So now look at these guys. So if this cancels, it means that our dy over dx will now be equals to 18x squared plus 6xy squared minus 200x divided by what? Minus 6x squared y. This is our final answer. That's our final answer. Alright? That's our final answer. Okay, so I've cleaned number 6 mistakenly. Alright, so okay. So that number 6, I'll be writing number 6 again, okay, so we can attempt it. Okay, but number 6, let me just explain number 6 so you do it. Now, what number 6 means is that when you differentiate that particular function, at your final answer, listen, are you listening to me? At your final answer, that is like you got this. Wherever you see x, put 1. Wherever you see y, put 1. Alright? So 1, 1, it's just a coincidence that both of them are the same value. But the first value is always for x, while the second value is always for y. So please attempt that. If you're online as well, attempt this question, your answer in the comment box below. Thank you. Alright, so I had to rewrite the question. So like I said, and I was explaining, what you just have to do, differentiate this implicitly. When you get a final answer, wherever you see x, put 1. Wherever you see y, put 1. Then solve. Look at the options here. Okay? So like I said, you tell me the right option that you got at the end of your calculation. Alright? So see you in the next class. Okay? See you in the next class. Subscribe if you have not. You can also share this video as well. Thank you.